Welcome back to the deep dive. Ever wondered if there's maybe more to managing your cholesterol than just diet, exercise, and, the usual prescription pills?
Oh, definitely.
Maybe
Yeah.
you've seen stuff online or heard about natural options and thought, do those things actually work? It feels like a space filled with a lot of hype, maybe some hope, but often, well, not a lot of clarity.
Absolutely. And cholesterol management, specifically dealing with high blood lipids, hyperlipidemia, as it's called, it's just so critical for heart health.
Right.
And yeah, conventional medicine has some really powerful tools, no doubt. But the reality of patient experience, dealing with side effects, or maybe just having a preference for more natural approaches, it kind of opens the door to exploring other possibilities.
Exactly. And that's precisely why we're here today. We're taking a deep dive into this stack of source material that you, our listener, provided. We've got research papers, clinical trial data, notes on traditional uses, mechanisms, safety profiles.
Yeah.
It's quite a bit. Our mission today is to navigate this pretty complex landscape. We're going to try and cut through some of the noise, pinpoint the really important bits of information, maybe uncover some surprising facts, and just help you get genuinely well-informed about how these different herbal and nutraceutical approaches stack up against or maybe even work alongside conventional therapies.
Think of us as your guides, maybe, through this information maze. We'll pull out the most relevant data from the sources, try to explain what it actually means, and help you understand the nuances, the good and the bad of these different approaches.
Okay, let's unpack this then. To really get a handle on the potential role of anything natural, we first kind of need to appreciate the established players, right?
Yeah.
The sources you shared give a pretty solid overview of the pharmaceutical landscape for managing hyperlipidemia.
That's really our starting point. For decades, statins have been the cornerstone. And the evidence, it's overwhelming. You look at trials like Jupiter, they showed statins aren't just about lowering the LDL-C, the bad cholesterol. They also have these really important anti-inflammatory effects. They benefit even people with normal LDL-C levels if their inflammation markers are high.
Right. And then HOPE-3 sort of extended their reach, didn't it? Showed clear benefits for preventing heart attacks and strokes in a broader group, people at intermediate risk.
Exactly. And then came Provy, which gave us that powerful idea that, within reason, lower LDL-C is better.
Yeah.
Getting to those lower targets with high-intensity statins really led to better outcomes for patients.
Okay.
And in Provy, that was a landmark study for ezetimibe. That's a medication that works differently. It blocks cholesterol absorption in the gut.
Oh, okay.
Adding ezetimibe to a statin, it gave further LDL-C lowering, and that translated into a significant reduction in cardiovascular events, especially in high-risk patients after, say, a heart attack. It really solidified the idea that how much you lower that LDL-C number matters, kind of regardless of the specific way the drug works.
And then there's the really cutting-edge stuff the sources cover, like the PCSK9 inhibitors, things like evolocumab and aleorcumab.
Yeah, those are incredibly potent. They often add another, 50–60% LDL-C reduction on top of statins. The big trials, Fourier and Odyssey outcomes, showed these huge reductions lead to significant decreases in major cardiovascular events, heart attacks, strokes.
Wow.
Now, these are generally reserved for the really high-risk patients or maybe those who just can't reach their goal with the oral meds. And the sources even mention evolocumab.
Evolocumab.
Yeah, it's an AGPTL3 inhibitor. It's a newer therapy for really severe cases like homozygous familial hypercholesterolemia, HOFH they call it, works through a completely different pathway, offering hope for patients with these really difficult genetic conditions.
So, okay, we've got these incredibly powerful, evidence-backed conventional tools. Statins, ezetimibe, PCSK9 inhibitors, even this evolocumab. But here's where we hit, a major snag in the real world. Something the sources really flags at the real world challenge.
Patient non-adherence to statins.
Yeah.
This is such a critical point, and it's honestly why exploring alternatives or adjuncts is so relevant. That UK Biobank study data the sources mention, it's really eye-opening.
How so?
Well, in those controlled clinical trials where patients are usually really diligent about taking their medication, statins achieve these robust LDL-C reductions, maybe around 38%. But in routine clinical practice, out in the real world, adherence is often much lower, and the average LDL-C reduction plummets to only about 15%.
Wait, hang on. 15% versus 38%? That's a 23 percentage point difference in how much their bad cholesterol is actually going down.
Exactly. And that massive reduction gap, just due to real-world non-adherence, it's often as large as, or maybe even larger than, the entire benefit seen in some clinical trials comparing an active drug to placebo.
Wow.
And the study confirmed this isn't just about numbers on a lab report. That lack of adherence translates directly to worse outcomes, a significantly higher risk of coronary heart disease for those who aren't taking their statin consistently.
That's a huge insight right there. It really tells us that even the most powerful drug isn't fully effective if people aren't actually taking it, whether it's because of side effects, real or perceived, or cost, or just forgetting. This adherence gap is a major public health issue. And that's precisely why people start looking for other options, right? Which brings us to this vast world of herbal and nutraceutical candidates.
Precisely. The sources you provided, they dive deep into a really wide range of these options used for hyperlipidemia, and they make it clear right away. The quality and the quantity of evidence supporting these, it varies dramatically.
How so?
You go from literally centuries of traditional use, often with pretty limited scientific validation, all the way up to, well-designed randomized controlled trials. But most options fall somewhere in between those two extremes.
Okay. Let's look at the breadth of candidates the sources mentioned then, because there are quite a few reviewed here.
There are. The sources cover about, roughly 19 different plants or plant-derived substances that have been either used traditionally or are being studied for lipid effects. It's a really diverse list, reflecting global traditions and also modern research efforts. They tend to broadly categorize these based on the strength of the evidence they found.
Okay, so maybe we can group them a bit like the sources do. We've got candidates with stronger evidence. Things like red yeast rice, berberine, and artichoke seem to be highlighted.
Right. Those are often put in a higher tier based on the clinical trial data.
Then maybe others with promising but perhaps less consistent data, like turmeric, garlic, and fenugreek.
Exactly. Still some decent human studies, but maybe more variability or questions.
And then there's this larger group where the evidence seems more preliminary, maybe based mostly on traditional use or lab studies or just very early clinical data, things like Googlewed, Aloe vera, Ginkgo biloba.
And then you have ones often seen in traditional Chinese medicine formulas like Kudzu root, Hawthorn, Danshen, Rhubarb, red peony root, Dangi, water plantain, Astragalus.
And even coriander seed extract is mentioned with preliminary evidence.
Right. It's a long list reflecting that wide exploration. And the sources are also careful to flag some things, like Sephora flavins, explicitly noting its toxicity and saying it's unsuitable.
That's important. It highlights that natural doesn't automatically mean safe, does it?
Not at all. That's a critical point.
It's fascinating just seeing the sheer volume of plant-based therapies that have been looked at globally for conditions that kind of align with what we now call hyperlipidemia. But like you said, the evidence isn't all equal.
Exactly. And that variability is the crucial insight when you look at this big list. Some have really been put through the ringer with rigorous modern trials, while others are still primarily supported by that traditional knowledge or very early research. To get truly informed, we really need to focus where the most compelling data lies, based on the source's own assessment.
Okay. And based on their detailed review looking at evidence, quality, efficacy, safety, the sources seem to identify a smaller group with higher potential, maybe categorizing them into tiers. So let's focus our deep dive on the 6 candidates that consistently appear in those higher tiers and have the most clinical trial data discussed in the sources.
Sounds like a good plan.
So that'd be red yeast rice, berberine, artichoke leaf extract, turmeric or curcumin, fenugreek, and garlic.
Right. Let's kick off with red yeast rice. This is probably one of the best-known herbal options out there for cholesterol. The sources explain it's produced by fermenting regular rice with a specific yeast, Monascus purpuris.
And the key reason it works, the sources explain, is because this fermentation process creates a group of compounds called monocolins, specifically one called monocolin K.
Yes, and this is the absolute key insight about red yeast rice's mechanism. Monocolin K is structurally and functionally identical to the prescription statin drug lovastatin. Identical. It works the exact same way. It inhibits the enzyme HMG-CoA reductase in the liver, which is that rate-limiting step in your body's own cholesterol production line.
So when people say red yeast rice is like a natural statin, they're not really wrong, are they? It literally contains the same active ingredient as an early statin drug.
Pretty much, yeah.
So what does the evidence from the sources show about its efficacy? How well does it work?
The sources detail that daily consumption of standardized red yeast rice products can reduce LDL-C, that bad cholesterol, by a significant 15–25% over about 6 to 8 weeks.
Okay, 15–25%. That's not trivial.
No, it's clinically meaningful. Meta-analyses mentioned in the sources found the average reduction is comparable to what you'd see with moderate intensity prescription statins, like, say, pravastatin 40 milligrams.
Okay, so it clearly affects the numbers on the lab report. But here's where red yeast rice seems unique among almost all the other natural options mentioned in the sources. It has outcome data, right?
This is where it gets really interesting and definitely sets it apart. The sources highlight the China Coronary Secondary Prevention Study, or CCSPS. This was a large, long-term clinical trial conducted in China with patients who had already had a heart attack, post-MI patients. They used a specific standardized red yeast rice extract called Sujicum.
And the findings were pretty dramatic, weren't they?
They were striking. Over about 4.5 years, the patients taking the standardized red yeast rice saw a 45% reduction in major coronary events.
45%?
Yeah, a 31% reduction in total coronary heart disease events, and nearly a 32% reduction in all-cause mortality dying from any cause.
Wow. That level of evidence showing actual reductions in heart attacks, strokes, and deaths, that's exceptionally rare for a non-prescription product, isn't it?
It really is. It suggests a potential benefit that goes way beyond just lowering the lipid numbers. However, this is a big however. The sources also temper this enthusiasm with some significant challenges and safety concerns.
Okay, like what?
Well, first, because it contains lovastatin, it can cause the typical statin-like side effects. Muscle pain or weakness. Myalgia is the main one people report.
Right, same as prescription statins.
Exactly. But perhaps the biggest concern, especially highlighted by the sources regarding the U.S. market, is around product quality and safety.
Consistency and contamination.
Absolutely critical. The lack of standardization in many commercially available red yeast rice products is a major issue. The actual amount of monocolin K can vary wildly from batch to batch, even within the same brand sometimes. So you might not be getting a consistent, effective dose.
That's not good.
And even worse, there's a significant risk of contamination with citrinin. Citrinin is a nephrotoxin. It can damage the kidneys. Many products tested have been found to contain it.
Oof. So even though that CCSPS data is really compelling, applying it in the real world is complicated because you don't really know if the product you're buying off the shelf is effective and safe.
Precisely. The sources really stress this lack of regulatory oversight and standardization as a major barrier to recommending it widely, at least outside of contexts where quality is rigorously controlled, like maybe in that specific Sujicum product used in the trial. And because its mechanism is identical to statins, it faces some of those same adherence challenges related to side effects.
Okay. Fascinating, but definitely complex. Let's move to the next one. The source is put in that top tier, Berberine.
Right, berberine. This is a bright yellow alkaloid compound. You find it in the roots, rhizomes, and bark of various plants. Things like barberry, golden seal, Chinese gold thread are common sources. It has a really long history of use in traditional medicine, particularly in TCM and Ayurveda.
And how does berberine work on cholesterol? According to the sources, is it another statin-like effect?
No, and that's what makes it really interesting. Its mechanism is quite different. It doesn't seem to directly inhibit HMG-CoA reductase like statins or red yeast rice. Instead, the main way it works is by increasing the activity and the stability of the LDL receptor, the LDLR in the liver.
The LDL receptor. Remind me what that does.
Think of the LDLR as the liver's cleanup crew. It sits on the surface of liver cells and grabs LDL cholesterol particles circulating in the bloodstream, pulling them out. Berberine essentially helps the liver make more of these cleanup crew members and keeps them working longer by stabilizing their mRNA, the instruction template.
Okay. So more LDL gets cleared from the blood.
Exactly. The sources also mention it has anti-inflammatory effects and might activate something called AMPK, which is an enzyme involved in cellular energy regulation. So multiple potential actions.
A completely different way to lower the bad cholesterol then, compared to statins or red yeast rice. What does the clinical evidence show for its efficacy? How well does it lower the numbers?
The meta-analyses cited in the sources consistently show significant improvements in lipid profiles. One review found average reductions of about 24 milligdl in total cholesterol, a pretty substantial 44 milligdl drop in triglycerides.
Wow, that's a lot for triglycerides.
Yeah, it seems quite effective there. And about 25 milligdl reduction in LDL-C. There was also a modest increase in HDL-C, the good cholesterol. Other reviews mentioned in the sources report LDL-C reductions generally falling in the 20-50 milligdl range, and those triglyceride reductions between 25-55 milligdl.
Those are quite impressive numbers,
Yeah.
especially the LDL reduction, putting it potentially in a range comparable to some prescription options like ezetimibe, maybe. The sources mentioned typical dosages are often around 500 milligrams, taken 2 or 3 times a day.
Hmm. Now, in terms of safety, berberine is generally considered well tolerated, but gastrointestinal side effects are pretty common. Things like constipation, diarrhea, gas, bloating, those pop up frequently in the studies.
Okay, typical GI stuff. Anything else unexpected?
There was one finding noted in the sources from a trial that was a bit puzzling. It actually increased testosterone levels in men.
Increased testosterone.
Yeah, it's kind of unexpected, especially because berberine is sometimes used in women with PCOS, where it often tends to lower elevated testosterone levels. So that's an interesting contrast that probably needs more research.
Definitely. What about more serious safety concerns or potential drug interactions? This seems to be a recurring theme.
Yes, and for berberine, this is a major point the sources emphasize, something that really cannot be overlooked. It has significant potential for drug interactions
Why is that?
because it inhibits several key liver enzymes that are responsible for metabolizing many medications. Specifically, it inhibits CYP3A4, CYP2D6, and CYP2C9.
Okay, CYP enzymes. What kind of common drugs are affected by those?
Oh, a huge range. The sources give examples like the immunosuppressant, drug cyclosporine, the common cough medicine dextromethorphan, the blood pressure medication losartan.
Wow, okay.
Taking berberine alongside these could significantly increase their levels in the body, potentially leading to increased side effects or even toxicity from the other drug.
So even though it's natural, taking berberine can be like adding another powerful drug into the mix that has really complex interactions with other meds someone might be on.
That's exactly the right way to think about it. And the sources strongly advise caution if you're taking medications for blood sugar, blood pressure, or blood thinners, because berberine could theoretically enhance the effects of those drugs too.
Got it.
And one more critical point. The sources note it's contraindicated, meaning it should not be used in newborns and during pregnancy. There's a risk of causing or worsening jaundice and potentially leading to kernicterus, which is a type of brain damage.
Okay, that's a very serious warning.
It is. But despite this significant interaction potential, its distinct non-statin mechanism is why the sources still view it as a strong candidate, particularly for patients who are statin intolerant, or maybe for use in combination with statins, but only if it's managed very carefully, likely with medical supervision.
That's a crucial nuance. Potentially useful, maybe even as an add-on, but absolutely requires careful medical oversight because of those interactions. Okay, let's move on to artichoke leaf extract. The sources also rank this one pretty highly in their top tier.
Right, artichoke leaf extract. This comes from the leaves of the common globe artichoke, the vegetable. Sonara cardunculus, specifically the scalamus variety. Traditionally, it's been used more for digestive issues and liver support.
Interesting. How does artichoke leaf extract supposedly help with cholesterol then?
The sources describe two primary mechanisms. First, it seems to stimulate the liver to produce and secrete more bile acids.
Bile acids, right, those are made from cholesterol.
Exactly. So by ramping up bile acid production, the liver uses up more cholesterol, helping to draw down the body's cholesterol stores. The second mechanism mentioned is that artichoke leaves contain certain compounds, particularly one called luteolin, which the sources suggest might also inhibit HMG-CoA reductase, that same enzyme statins target.
Ah, so maybe a little bit of a statin-like effect too.
Potentially, though, likely not nearly as potent as actual statins or the monocolin K in red yeast rice. The sources also mention it has antioxidant properties, which could add some broader cardiovascular benefits beyond just lipids.
So it seems to work through multiple pathways, one related to bile, maybe a weaker statin-like effect, plus antioxidant action. What about its efficacy in clinical trials? Does it lower the numbers?
Yes, the meta-analyses reviewed in the sources show significant effects. On average, they found reductions around 17.6 mg/dL for total cholesterol, about 14.9 mg/dL for LDL-C, and roughly 9.2 mg/dL for triglycerides. HDL-C, the good cholesterol, generally wasn't significantly affected.
Okay, those reductions, especially for LDL-C, around 15 mg/dL, that's definitely meaningful. Maybe a bit less potent on average than what was cited for berberine or red yeast rice, but still clinically relevant, seems like. The sources mentioned dosages typically ranging quite a bit, from 500 up to 2,700 milligrams per day in the studies.
Right. Now, here's a really key insight from the sources regarding artichoke safety.
Well,
They specifically highlight its exceptionally favorable safety profile.
oh, that sounds good. Exceptionally favorable.
Yeah, that's the phrase used. It's generally very well tolerated. The main side effect reported is just occasional mild GI upset, like gas or mild diarrhea.
That sounds very appealing, especially compared to the interaction profile of berberine or the contamination risks with red yeast rice.
Yeah.
Are there any significant safety concerns or interactions to be aware of with artichoke?
The main precaution noted by the sources relates back to that bile-stimulating effect. Because it increases bile flow, it should probably be used with caution, or maybe avoided altogether, in people who have gallstones or any kind of obstruction in their bile ducts. Increasing bile flow in that situation could potentially cause problems, like a gallbladder attack.
Okay, that makes sense. Anything else? Allergies.
There's a theoretical risk of allergic reaction, particularly for people who are sensitive to other plants in the Astraceae family. That's the daisy family. Includes things like ragweed, chrysanthemums, marigolds.
Ah, the allergy connection.
Right. And theoretically, it could interact with anti-diabetic or antihypertensive drugs, or maybe drugs metabolized by the liver, but the sources don't really flag any major high-risk interactions like they did for berberine or even garlic. So overall, its excellent safety profile combined with decent efficacy really makes it stand out as a potentially attractive option in the source's view.
Okay, good to know. Let's move down the list now to what the sources maybe consider the next tier of promising candidates. First up here is turmeric, or maybe more specifically, its active compound, curcumin.
Right, turmeric comes from the rhizome, the root-like stem of the Curcuma longa plant, famous for its vibrant yellow color, of course, and its central role in Indian and Southeast Asian cuisine and traditional medicine, like Ayurveda. Curcumin is the main active compound, the primary curcuminoid, that's thought to be responsible for many of its biological effects.
We hear a lot about turmeric for inflammation. How does it actually fit into cholesterol management, according to the sources?
That's exactly it. The sources explain that curcumin's primary mechanisms relevant here are its really powerful anti-inflammatory and antioxidant properties.
How does it do that?
It seems to work partly by activating something called the NRF2 pathway, which basically boosts the body's own natural antioxidant defenses. And it also inhibits NFB, which is a key signaling molecule that drives inflammation. So by tackling inflammation and oxidative stress, it's thought to contribute to overall cardiovascular health, and that includes potential positive effects on lipid levels.
Ah, okay. So it's not necessarily directly hitting a cholesterol-making enzyme like statins or directly affecting receptors like berberine seems to, but it's more broadly impacting those underlying factors like inflammation and oxidative stress.
That seems to be the main thinking outlined in the sources, yes.
So what does the evidence show for its direct effect on the lipid numbers then?
Recent meta-analyses cited by the sources do show positive results. They indicate significant, albeit maybe more modest, reductions in total cholesterol around 7.76 milli-GDL on average. LDL-C reduction was about 5.84 milli-GDL, and triglycerides dropped by around 13.15 milli-GDL.
Okay, so maybe smaller reductions than the first three we discussed.
Generally, yes. But interestingly, those meta-analyses also found a significant increase in HDL-C, the good cholesterol, by about 2.4 milli-GDL.
Oh, an HDL boost, that's a notable difference.
It is, and the sources mention these benefits seem to be more pronounced in patients who also have underlying metabolic conditions like type 2 diabetes or non-alcoholic fatty liver disease, NAFLD. That kind of supports the idea that its effects on inflammation and metabolic dysfunction are key.
Right. But there's a catch with turmeric, isn't there? Something about getting it into your system.
Yes, absolutely crucial point the sources highlight: poor bioavailability. Standard curcumin, like you'd get from just the spice, is not easily absorbed into the bloodstream. For it to be effective for these systemic effects, the sources stress you often need special formulations designed to enhance absorption.
Like what?
Things like combining it with piperine, which is the active compound in black pepper, or using specific delivery systems like phytosomes or nanoparticles. These help get more curcumin into your body where it can actually work.
Ah, okay, so just eating more curry, while delicious, might not be enough to get these specific effects. You likely need a specific type of extract or supplement formulation.
That seems to be the consensus in the research discussed, yes.
What about safety for turmeric or curcumin?
Generally considered very well tolerated. Mild GI upset is possible, like with many supplements. The sources do mention a potential increased risk of kidney stones, specifically oxalate stones, in people who are already susceptible to them.
Okay, interaction.
Potential interactions exist, particularly with anticoagulants or antiplatelet drugs, blood thinners, due to potential effects on clotting. Also, possible interactions with some chemotherapy drugs, the immunosuppressant tacrolimus, and certain drugs metabolized by those CYP450 liver enzymes we mentioned earlier.
Okay. Next promising candidate from the sources list is Fenugreek.
Fenugreek, Trigonella phonum graecum. This is both an herb and a spice, used really widely in Indian, Middle Eastern, and North African cooking, and also in traditional medicine systems in those regions. It often comes up in discussions about benefits for both blood sugar control and lipid levels.
Right, I've heard about it for blood sugar. How might fenugreek affect cholesterol? What's the mechanism?
The sources mention a couple of possibilities. Fenugreek is rich in fiber and compounds called saponins. These could potentially work in the gut to inhibit the absorption of dietary cholesterol and also bile acids, forcing the liver to use more cholesterol to make new bile acids.
Similar to how artichoke works with bile acids then.
Somewhat similar mechanism proposed, yes. The sources also note there's some suggestion of possible inhibition of HMG-CoA reductase, that statin target enzyme again, although they don't detail the mechanisms as extensively as they did for red yeast rice or even artichoke.
Okay. What does the clinical evidence say about its efficacy? Does it work on the numbers?
A meta-analysis of 15 randomized controlled trials, which was reviewed in the sources, found significant reductions in total cholesterol, LDL-C, and triglycerides. And interestingly, like turmeric, it also showed a significant increase in HDL-C.
Another HDL booster.
Seems so. And the sources note that these positive effects on lipids were particularly pronounced in the study participants who also had diabetes. While the summary table in the source doesn't give specific average percentage reductions for fenugreek, it's consistently listed as showing significant improvements across multiple lipid markers in these analyses.
So promising effects on the lipid panel overall. Now, let's talk safety.
Okay. Common side effects are, again, mostly gastrointestinal things like upset stomach, bloating, diarrhea. But the sources do flag some more serious potential side effects that need attention. Hypoglycemia, which is low blood sugar.
Right, makes sense given its use for blood sugar control.
Exactly. And also hypokalemia, which is low potassium levels.
Hypoglycemia and hypokalemia. Those sound like things you need to be very careful about, especially if someone is already on medications for diabetes or maybe blood pressure.
Absolutely. And this leads directly to a pretty significant interaction profile highlighted by the sources. Fenugreek can definitely have additive effects with anti-diabetic medications, significantly increasing the risk of dangerously low blood sugar.
Okay.
It can also potentially interact with anticoagulants like warfarin, possibly increasing bleeding risk. And because it can lower potassium, using it with potassium-lowering diuretics, certain blood pressure pills, could raise the risk of hypokalemia.
So that interaction profile seems quite significant.
It is. Its potential to significantly impact blood sugar and potassium levels, plus the bleeding risk interaction, means its target market is probably narrower, and it really requires careful medical oversight, especially if someone has underlying conditions or is on other medications. The sources also list pregnancy as a key contraindication for fenugreek.
Good to know. That interaction profile is definitely a major point to consider. Okay, and finally, for our group of 6, let's look at garlic, the common culinary ingredient, Allium sativum.
Right, garlic. Probably one of the most widely used traditional medicines around the globe. Its potential benefits for cardiovascular health have been studied for decades, although, as the sources note, the evidence specifically for lipid lowering is actually a bit inconsistent.
Inconsistent, okay. How is garlic thought to work on cholesterol then? Is it another HMG-CoA reductase inhibitor?
Well, the sources mention a putative, meaning supposed or suggested inhibition of HMG-CoA reductase, similar to statins, but they are quick to point out that this finding hasn't been consistently replicated across different studies.
Ah, okay.
Yeah.
So maybe not.
Exactly. What seems more consistently recognized is garlic's contribution through other mechanisms. Its antioxidant effects, its antiplatelet or blood thinning effects, and its vasodilatory effects helping blood vessels relax. These are thought to be mediated by sulfur compounds, like the famous allicin, and also by promoting the production of nitric oxide, NO, and hydrogen sulfide, H2S, in the body.
So it seems like garlic might be working more on broader aspects of vascular health, like blood flow and clotting, rather than directly and powerfully targeting cholesterol production itself.
That seems to be a fair summary based on the sources. And that potential inconsistency in the direct lipid mechanism might help explain why the clinical evidence on its lipid-lowering effects is kind of conflicting.
Okay, so what does the clinical evidence from the sources tell us about its effect on cholesterol numbers?
This is where it gets a bit muddled, honestly. Different meta-analyses seem to reach different conclusions, which the sources acknowledge. One updated review they cited found modest reductions, maybe around 17 milligdl for total cholesterol and about 9 milligdl for LDL-C. But these effects were primarily seen in people who started with higher baseline cholesterol levels.
Okay, modest, and maybe only if your cholesterol is high to begin with.
Right. Another review mentioned found about a 12% reduction in total cholesterol overall. But then other analyses cited found no significant effect on lipid levels at all compared to placebo.
So the key insight here seems to be that unlike, say, red yeast rice or berberine, where the evidence for lowering LDL seems more consistent, the data for garlic's effect on lipid numbers is quite mixed and maybe only modest even when it's positive.
That seems to be the takeaway from the sources, yes. The signal is less clear and less strong compared to some of the others.
What dosages were used in the studies that did show an effect?
The sources indicate typical dosages in those positive trials were around 600 to 900 milligrams per day of a standardized garlic powder extract. However, they immediately highlight the lack of standardization in many commercial garlic products and the inherent instability of the key active compounds, especially allicin, as major challenges. This likely contributes significantly to the inconsistent results seen across studies.
Another quality control issue like with red yeast rice, but maybe more about the compound stability here.
Seems like it, yes. Making sure you have enough active, stable compound in the supplement is key and apparently difficult with garlic.
And safety for garlic, beyond, the famous smell.
Right. Well, the common side effects are indeed bad breath, body odor, and sometimes gastrointestinal upset. But the most significant safety concern noted by the sources is an increased risk of bleeding.
The blood thinning effect.
Exactly. It can interact significantly with anticoagulant medications like warfarin, potentially increasing their effect and the risk of bleeding complications. Because of this, the sources strongly recommend stopping garlic supplements well before any planned surgery.
Okay, crucial point for anyone on blood thinners or having surgery. Any other interactions?
It might also interact with some blood pressure medications and potentially with certain HIV drugs, protease inhibitors.
Okay, so summarizing these 6 candidates, we've dived into red yeast rice, berberine, artichoke, turmeric, fenugreek, garlic. It's really clear there's a huge range, different ways they might work, different levels of effectiveness reported, and really importantly, very different safety profiles and potential for interactions.
Absolutely. The key takeaway is that while some definitely show promising effects on lipid numbers, red yeast rice, berberine, and artichoke perhaps being the most notable in terms of LDL reduction magnitude and consistency in the sources, they are all biologically active substances. They come with real risks, real contraindications, and in some cases, like berberine, fenugreek, and garlic, significant potential for drug interactions that absolutely demand careful consideration and probably professional guidance. Artichoke stands out for its generally favorable safety profile, which is a plus, and red yeast rice has that unique issue of needing rigorous quality control to avoid contamination and ensure potency, plus the statin-like side effects.
This complexity is probably why the sources also spend some time looking at more integrated approaches, particularly drawing from traditional Chinese medicine or TCM. How does TCM view something like high cholesterol, and what does the research show about maybe combining TCM approaches with conventional ones?
That's a really interesting section in the sources. They explain that TCM generally doesn't treat an isolated number like high cholesterol. Instead, it looks at patterns of imbalance or disharmony in the whole person. Hyperlipidemia might be seen as related to patterns like phlegm dampness, blood stasis, or liver key stagnation, for example.
So they use formulas targeting these patterns.
Exactly. They use multi-herb formulas tailored to the individual specific pattern. The sources mention examples like a formula called Tiaozi Yangan decoction, which has been studied in patients with non-alcoholic fatty liver disease, often linked with metabolic issues, including hyperlipidemia, and shown improvements not just in liver function, but also in lipid profiles. Other classical formulas like Dachai Hu Tang might be used for certain accumulation patterns sometimes associated with high lipids.
Okay. And there was a really intriguing finding mentioned in the sources about actually combining TCM formulas with conventional statin therapy, wasn't there?
Yes, this is a potentially very significant area the sources highlight. They discuss a network meta-analysis, a study that statistically combines data from multiple trials, which specifically looked at combining various Chinese patent medicines, these are standardized commercially available multi-herb formulas, with atorvastatin, which is a very common statin.
What did they find?
They found that certain combinations, for example, one called Dantian Jiangxi granules plus atorvastatin, actually showed significantly greater effects on lowering total cholesterol, triglycerides, and LDL-C compared to taking atorvastatin alone.
So potentially enhanced efficacy by combining, like
Yeah.
1 + 1 = 3.
Potentially, yes, for lowering the numbers. Another example mentioned was Swijikong, which is that standardized red yeast rice extract we talked about from the CCSPS trial. When added to atorvastatin in this meta-analysis, it showed particular effectiveness for raising HDL-C, the good cholesterol.
Okay, better numbers potentially. But wasn't there something even more striking about side effects?
Yes, and this is the finding highlighted by the sources that could directly address that huge, real-world challenge of statin adherence we discussed at the beginning. The meta-analysis found that combining these Chinese patent medicines with atorvastatin was associated with approximately half the incidence of adverse reactions compared to taking atorvastatin alone.
Wait, half the side effects? Just by adding the TCM formula?
That's what the analysis reported. The adverse reaction rate was around 5.6% in the combination groups versus about 11% with atorvastatin monotherapy.
That's a massive difference. If that's real and can be validated, that could potentially change how people tolerate statins and maybe help them stick with the therapy.
It really could. The hypothesis put forward in the sources is that the complex multi-target effects of these traditional formulas might somehow help counteract or mitigate some of the common side effects caused by statins, maybe muscle symptoms, maybe liver enzyme elevations.
Interesting.
If this proves true in larger, more rigorous, well-designed trials, it wouldn't necessarily be about choosing a TCM formula instead of a statin, but potentially finding a synergistic partner that could improve both the efficacy and the tolerability of statin therapy. This is framed in the sources as a key insight with major potential implications for improving patient care.
Wow. That could be incredibly powerful for improving long-term outcomes if it genuinely helps more people stay on their proven statin medications.
Absolutely. It shifts the focus from just alternatives to potentially beneficial integrations.
Okay, so when we step back and try to compare the evidence across all these different options, the pharmaceuticals, the biologics like PCSK9 inhibitors, and then this wide array of herbal and integrated approaches, a pretty clear hierarchy seems to emerge, doesn't it?
Yeah.
Based on both the sheer power to lower LDL-C and, maybe more importantly, the strength of evidence proving they actually prevent cardiovascular events.
Definitely. Let's look at the LDL-C lowering potential first, just the raw power to bring the number down based on the sources.
Okay.
At the very top, offering the most potent LDL-C reduction, often 50–60% or even more, especially when added to other therapies, are the injectable biologics, the PCSK9 inhibitors, and that newer AGPTL3 inhibitor, evinacumab. These are particularly vital for those really severe genetic conditions like FAFH.
Right, the heavy hitters.
Then you have intensive statin therapy, often combined with ezetimibe, which aims for maybe a 50–60% reduction from baseline. Standard statin therapy, used alone, reliably provides maybe a 30–40% reduction.
Okay, so where do the herbs we discussed fit into that scale, generally?
Well, the higher evidence nutraceuticals, like a well-standardized red yeast rice, offer a solid 15–25% reduction, according to the sources. Others with pretty good data, like berberine and artichoke leaf extract, seem to show reductions generally falling in the 10–25% range in various studies cited.
So significantly less potent than high-intensity statins or the biologics.
Definitely less potent in terms of pure LDL lowering power, yes. However, the reduction levels, say 15–25%, are actually quite comparable to, or maybe even potentially exceed, what you might get from using ezetimibe alone, though ezetimibe is usually used with a statin. So they're not insignificant, but not in the same league as the top-tier pharma options for potency.
Okay. But the really critical difference, as the sources seem to emphasize repeatedly, is the outcome evidence, right? Does lowering the number with these different agents actually translate into fewer heart attacks and strokes in large trials?
This is probably the starkest contrast highlighted in the sources. For statins, for ezetimibe, especially when added to statins, and for the PCSK9 inhibitors, we have mountains of high-quality data. Decades of research, multiple large, randomized, controlled clinical outcome trials, CVOTs, showing a clear, undeniable reduction in cardiovascular events. We know they save lives and prevent heart attacks and strokes based on this rigorous evidence.
Okay, and for the herbal and nutraceutical options?
For most of those reviewed, the evidence is primarily limited to showing effects on surrogate markers, things like lipid levels, maybe inflammation markers. That crucial large-scale outcome data demonstrating a reduction in actual heart attacks, strokes, or deaths is largely missing.
So changing the number on the lab report is definitely important, shows biological activity. But proving that change prevents the actual health crisis people are trying to avoid. That's the gold standard of evidence, and it's largely absent for most of these herbs.
Precisely. That's the critical distinction the sources make. The one exception, as we discussed, is red yeast rice, specifically the Jinkgo extract used in that large CCSPS trial in China. That did show a significant reduction in cardiovascular events.
Right. So why isn't it considered on par with statins then?
Well, the sources are careful to note a few things. It was one large trial conducted in a specific population, post-MI patients in China. The findings haven't been replicated in similar large-scale trials elsewhere. And there's the ongoing issue of ensuring consistent product standardization and safety outside of that specific trial context. So while the CCSPS result is incredibly intriguing and important, it doesn't yet place red yeast rice on the same level of irrefutable, globally replicated outcome evidence that we have from decades of statin research involving hundreds of thousands of patients worldwide.
That's a really, really important distinction for anyone considering these options. It's about understanding not just if something works, but the strength and type of evidence behind how well we know it works and for what outcomes.
Exactly. You need to weigh the evidence appropriately. And hand in hand with efficacy is, of course, safety and tolerability. The sources provide a helpful summary comparing the safety profiles across these different options, which is just as critical.
Yeah, we touched on some of the individual issues as we went through the top 6, but what are the key safety insights when you look across the board based on the sources?
Well, common gastrointestinal issues are definitely a recurring theme for many of the herbal options we discussed. Berberine, artichoke, fenugreek, garlic, turmeric, and even red yeast rice can cause some GI upset.
Okay.
A major cluster of concern highlighted involves bleeding risk and potential interactions with anticoagulant or antiplatelet medications, blood thinners. This is particularly prominent for garlic and fenugreek, but it's also mentioned as a potential issue for turmeric, and several herbs often used in TCM like Danshen, Hawthorn, Kudzu root, Puraria, Astragalus, and Coriander. If you're on a blood thinner like warfarin, clopidogrel, or even aspirin, this list is absolutely critical to review with your doctor before considering any of these.
Definitely. What about effects on blood sugar?
Yes, that's another key area. Potential lowering of blood sugar and interactions with anti-diabetic medications are significant concerns noted for fenugreek, but also potentially for aloe vera, kudzu root, puraria, astragalus, coriander, and maybe even artichoke to some extent. Again, really crucial if you have diabetes or prediabetes or are taking medications for blood sugar control.
Okay. And what about those more specific, unique risks tied to certain herbs?
Right. We have berberine's risk of kernicterus in newborns and during pregnancy, which is specific and severe. Red yeast rice has that ongoing significant risk of contamination with the kidney toxin citrinin, especially if you're not using a product from a highly trustworthy certified source. Artichoke and coriander carry those potential allergy risks, particularly for people with sensitivities to related plant families, like ragweed for artichoke. The sources also briefly mention potential hormonal effects, like estrogenic activity suggested for guggul and kudzu root, puraria, or potential immune system stimulation from astragalus, which could theoretically limit their use in certain populations, like those with hormone-sensitive cancers or autoimmune conditions.
It really drives home the point, doesn't it, that natural absolutely does not mean risk-free or interaction-free. These are potent biological substances.
Absolutely. They have real pharmacology, they have contraindications, they have significant potential to interact with prescription medications. This requires the same level of careful medical consideration as any prescription drug. It really reinforces the need for professional guidance from a doctor or pharmacist who knows your full health history and medication list, rather than just self-treating based on something you read online.
For sure. But circling back to that potentially really positive finding from the TCM research, the sources do offer this intriguing glimpse of hope regarding tolerability by highlighting the potential for some of those TCM combinations to actually reduce statin side effects.
Yes, that hypothesis, while definitely needing more rigorous confirmation in large trials, is presented as a potential bright spot. It suggests that future integrated approaches might not just be about adding efficacy, but could also potentially improve the overall safety and tolerability profile compared to using statins alone.
Okay, so bringing all of this evidence together, the potency, the outcome data, or lack thereof, the safety profiles, the interactions, the potential for synergy, it really underscores the importance of personalized therapy when it comes to managing cholesterol, doesn't it?
Yeah.
How does the picture painted by these sources help guide treatment strategies for different kinds of individuals?
The sources illustrate this quite clearly by outlining different scenarios. For instance, take a very high-risk patient, maybe someone who's just had a heart attack or stroke, secondary prevention. The evidence-based pathway laid out is aggressive conventional therapy first, meaning high-intensity statin therapy is the foundation. If LDL goals aren't met, add ezetimibe. If goals still aren't met or the risk is extremely high, consider adding a PCSK9 inhibitor. The overwhelming positive outcome trial data for these medications in this high-risk population is simply unmatched by any herbal option discussed.
So, for aggressive secondary prevention, conventional therapy is clearly the primary route based on the strongest evidence for preventing future events.
Precisely. But now consider the statin-intolerant patient, a very common scenario in the real world, directly related to that non-adherence problem we talked about. The sources discuss the standard approaches first, trying a different statin, as tolerance can vary, using lower doses, or maybe combining a low-dose statin with ezetimibe.
Okay.
For those who are genuinely intolerant to all statins, ezetimibe used alone, or potentially a PCSK9 inhibitor, are the main evidence-backed non-statin options with proven outcome benefits.
And this is a space where some of the evidence-backed herbs we discussed might potentially find a role, according to the sources.
Yes, this is where the sources suggest they might be considered carefully. For statin intolerance, a rigorously selected high-quality red yeast rice product could be an option, but again, always acknowledging that it fundamentally is a statin, lovastatin, and carries similar side effect risks and those crucial quality control issues.
Right.
Berberine or artichoke leaf extract, given their reasonable efficacy data and completely different mechanisms of action, are also presented in the sources as potential options to explore for patients truly intolerant to statins, always weighing the benefits against their specific safety and interaction profiles.
And that potential for certain TCM combinations to maybe improve statin tolerability could also fit in here.
Exactly. That adds another dimension to exploring integrated strategies, particularly for those struggling with statin side effects, although more research is needed to confirm that benefit.
What about those really severe genetic conditions like homozygous familial hypercholesterolemia, HoH?
There, the sources highlight that newer biologic, evinacumab, the NGPTL3 inhibitor, as a real breakthrough. It's often considered a first-line biologic therapy for these patients because its powerful mechanism works independently of the LDL receptor, making it particularly suitable for these very difficult-to-treat genetic cases.
Okay. And what about primary prevention? Someone who hasn't had an event yet, but maybe has elevated cholesterol and wants to lower their future risk.
It's entirely risk stratified, as the sources explain. For someone at moderate cardiovascular risk with elevated LDL-C, a moderate intensity statin is typically the standard recommendation based on large primary prevention trials like HOPE-3. For someone with lower LDL-C but maybe high inflammation, high hsCRP, a statin might still be considered based on the Jupiter trial findings. However, for a genuinely low-risk individual, perhaps with only mild hyperlipidemia, who strongly prefers to explore non-prescription options first, the sources emphasize that intensive lifestyle modification diet, exercise, weight management is always the absolute first step. If lipids remain elevated after that, then potentially considering one of the higher evidence nutraceuticals like a high-quality red yeast rice, berberine, or artichoke could be discussed, but always with the clear understanding of the limitations and outcome data compared to statins, and careful consideration of safety and interactions.
So the approach really becomes highly personalized. You have to factor in the patient's overall cardiovascular risk, their tolerance for medications, their personal preferences, and critically, the specific level and type of evidence available for each potential option, including the herbs.
Exactly. It's not about wholesale replacing conventional medicine, which has robust outcome data, but about understanding where different evidence-based tools, which might include some of these carefully selected and monitored herbal options, could potentially fit into a comprehensive, tailored strategy for an individual patient. However, the sources are also very clear about pointing out significant gaps in our current knowledge and identifying critical areas for future research.
Okay. What are the key questions the sources suggest still need answering? Where are the big unknowns?
Well, they mention the need for more long-term safety and efficacy data, especially for the newer biologics like PCSK9 inhibitors and evinacumab data extending beyond the initial 3 to 5 year trial periods.
Yeah.
There's also a clear need, they suggest, for more head-to-head clinical trials directly comparing different non-statin drugs or even comparing the most promising herbal candidates against each other or studying them specifically as add-ons to statin therapy.
And specifically regarding the herbal candidates themselves, what's the most crucial missing piece?
For herbs like berberine and artichoke leaf extract, which show promising effects on lipid numbers and have decent safety profiles, the sources stress the urgent need for large, rigorous, randomized controlled trials that are specifically designed to measure hard cardiovascular outcomes.
Meaning heart attacks, strokes, deaths.
Exactly. We need to know if lowering LDL by 15–25% with berberine or artichoke actually translates into fewer heart attacks and longer lives, the way we know it does for statins. Without that definitive outcome data, they will likely remain secondary or alternative options in most guidelines, despite their effects on the surrogate lipid markers.
That makes sense. And what about that intriguing finding about TCM synergy reducing statin side effects?
That hypothesis also desperately needs validation, according to the sources. They call for large, well-designed, rigorous clinical trials to definitively confirm whether specific, standardized TCM formulas can truly mitigate statin side effects and improved adherence rates across diverse patient populations. If confirmed, that could be huge.
Yeah. The sources even briefly touch on the ongoing challenges in developing things like PCSK9 vaccines, which could potentially offer a revolutionary long-acting treatment approach in the future, moving away from frequent injections.
Right. These evidence gaps and research needs are actually really exciting areas. They show how much potential there still is to refine and improve how we manage hyperlipidemia. Rigorous research addressing these questions could lead to fundamentally new treatment paradigms, or perhaps allow us to integrate existing traditional methods into mainstream care in a much more evidence-based and effective way than we currently can.
This has been a truly deep dive, hasn't it? We've gone from the most potent modern biologics all the way back to ancient herbal traditions used for centuries.
We really have, and I think the key takeaways from the sources are pretty clear. Conventional pharmaceuticals, particularly statins and the newer biologics, are incredibly effective at lowering LDL-C and, most importantly, have strong evidence for preventing cardiovascular events. But real-world adherence, especially to statins, is a major hurdle limiting their full potential.
Right. And on the other side, many herbal candidates show promise, at least for improving lipid numbers on paper. But the quality and type of evidence backing them varies hugely.
Exactly. Some, like red yeast rice, berberine, and artichoke, seem to have more solid data regarding their effects on cholesterol levels. But critically, they largely lack that robust, replicated cardiovascular outcome evidence that the mainstream pharmaceuticals have accumulated over decades.
And we've certainly learned that natural definitely doesn't mean risk-free. Safety profiles, contraindications, and especially those potential drug interactions are absolutely vital considerations for all options, prescription or otherwise.
Couldn't agree more. And yet there's also that intriguing potential highlighted in the sources for integrated approaches, particularly the idea of combining traditional medicine, like specific TCM formulas, with conventional drugs, which might, if proven, not only add efficacy, but potentially improve tolerability and adherence too.
So, thinking about all this, let's end with a provocative thought. Based on everything we've unpacked from these sources, what might cholesterol management actually look like in the not-too-distant future, say, maybe 5 or 10 years from now, if some of these research pathways we discussed actually prove successful?
Well, it's fascinating to speculate based on the possibilities raised. If, for instance, large outcome trials for promising herbs like berberine or artichoke leaf extract actually come through positive, demonstrating a clear reduction in heart attacks and strokes.
Yeah.
Or if future studies definitively prove that certain well-characterized, standardized, integrated TCM approaches genuinely improve statin adherence and significantly reduce side effects, then we could potentially see treatment guidelines start to incorporate these options much more formally than they do now.
So maybe doctors would have more evidence-based options in their toolkit.
Potentially. We might see the development and validation of specific, high-quality, standardized natural products that are explicitly designed and proven to be used alongside conventional therapy in certain patient groups. The approach could become even more personalized, perhaps even factoring in individual patient risk profiles, genetic factors influencing response or side effects, and patient preferences more systematically.
So imagine a future where managing cholesterol isn't just about automatically prescribing a statin, but maybe selecting from a wider, yet still rigorously evidence-based toolkit. A toolkit that might include highly effective pharmaceuticals, powerful biologics, and carefully studied, validated natural and traditional approaches, all aimed at making therapy more effective for the individual, better tolerated, and ultimately helping people actually stick with it long-term to prevent heart disease.
That kind of true integration, driven by solid scientific research that directly addresses the current evidence gaps the sources identify. That's a truly fascinating possibility hinted at here. It really moves beyond that simplistic, often unhelpful, either debate of conventional versus natural, and looks towards a potentially more personalized, synergistic, and ultimately more effective approach to managing this critical aspect of health.
That's a powerful and actually quite hopeful thought to end on. Thank you so much for guiding us through this really complex and sometimes surprising world of cholesterol management as presented in these sources.
My pleasure. It's clear that understanding the evidence, both the strengths and the gaps, is absolutely key for anyone trying to make informed decisions about their health in this area.
Indeed it is. And thank you all for joining us for this deep dive. We hope it's given you a clearer perspective and perhaps some thought-provoking ideas about the current state and potential future of managing cholesterol.